So there's roughly 1 billion people in the world without access to clean and safe drinking water, and because of that, many of them get sick, get diarrhea, and even die from pathogens within the water. And so for years, people have been looking for very cost-effective methods of treating water, and one of the most cost-effective method is the SODIS method. The SODIS method stands for solar water disinfection. You use clear plastic bottles like this, fill them up with water about 3/4 full, shake it to put some oxygen in the water, and then place them in direct sunlight for 6 hours on their side. And as long as the water is clear enough, the combination of UV radiation and thermal radiation kills the pathogens in the water and makes it safe to drink. And so this has already been rolled out to millions of people all over the world. It's very effective if you have relatively pure, relatively transparent water to begin with. And so what our research looked at is, well, what about for the people that don't have clear water, that have turbid water that's dirty, particularly in the developing world and tropical regions? You have areas of clays, high activity clays, that get suspended in the water and make it so that this method doesn't work. So you can think of the pathogens as sort of hiding underneath dirt particles. UV radiation can't hit them, and so it just doesn't function. And so our research looked at another cheap, highly deployable, highly generalizable method of being able to reduce the turbidity in the water so that people could use the SODIS method. And what we specifically looked at was using salt. So salt, common everyday table salt, you have some at home. When added to water with high activity clays like bentonite suspended in it, actually causes the clay particles to stick together and flocculate to fall out of the suspension. And then you can kind of take the clean water off the top, put it in the SODIS bottle, and you're good to go. And so our research showed that it absolutely works, first of all. And we also monitored the salt content of the water afterwards. And our goal was to try to get the absolute minimum amount of salt that you'd have to add to the water of a specific type of clay and at a specific kind of density in order to not only reduce the cost so you wouldn't use as much salt, but also make sure that the salt content was safe for human consumption. And the good news is we found in several of the different samples, depending on what type of clay it was and how much there was in the water, the salt concentration was less than that of Gatorade. So it's safe to drink and makes this method of cleaning drinking water actually viable. There's a very easy method to determine the turbidity of water that makes it safe enough to drink with the SODIS method, and that's a turbidity test by reading through the water. And so you place your water bottle over top of, say, a newsprint, and if you can read the headline, then that means that the turbidity is low enough that the SODIS method will work. And so you can do experiments with the water in your own community, adding different levels of salt to it, and then working with the minimum one that gives you enough clearness to make the method work. It's a very simple technology, but it's a technological solution to really a social problem.